Okay, so this problem involving trig functions is what we've been doing. You just have to approach it a little bit differently. So first off, let's look at what it's asking. So this says, let cosine theta equal 2 over 7, and 0 is less than theta, which is less than pi over 2. Okay, so first off, this should look familiar. This part, maybe not so much, right? So all this is saying is that if you draw 4 quadrants, the angle is going to be between 0 and pi over 2. So this is 0, this is pi over 2, right? So pi over 2 is the same thing as saying 90 degrees. So what this means is this angle is somewhere between 0 and 90 degrees, right? So maybe, I don't know, maybe it's like that, right? It's somewhere in this first quadrant. That's all this says, right? So really what we're looking at is this part. Cosine theta equals 2 over 7. Okay, so let's apply what we know to try to solve this, right? So I see cosine. I know that cosine theta is the adjacent side over the hypotenuse, right? So let me draw a triangle, right? So here's some random triangle, and it's not going to exactly be to scale, but it'll work. So cosine is adjacent over hypotenuse. I'm going to define my angle down here, right? And I know cosine theta is 2 over 7 from the problem. So adjacent over hypotenuse, 2 over 7, well, I can make these numbers match up, right? So cosine is equal to that, but it's also equal to 2/7. So if 2 is in the numerator, that's the adjacent side. Here's my angle. The side touching is adjacent, so this side is going to be 2. And the hypotenuse is in the denominator, right? So 2 over 7, hypotenuse 7, right? So that's going to be 7. So now, if I'm going to solve some stuff, I don't know this side, right? So see how, here's the first one. I need to find sine theta. Sine is opposite over hypotenuse, right? So I know right away I need to solve for this side, right? I was given this from the problem, but I don't know this side. So how do we do that? Well, we start with Pythagorean theorem, right? So I'll do it over here. A squared plus b squared equals c squared. So what's a, b, and c, right? What goes where? So we should know that c has to be the hypotenuse, right, in Pythagorean theorem, and the other two, it doesn't matter, so I'm just going to call this one a, and I'll call that one b, right? Doesn't make any difference which one you call which, as long as c is the hypotenuse. So I need b, right? I need to isolate b. Let me get b by itself, right? So I'll subtract over a. I'll subtract a squared from both sides, and I'll get b squared equals c squared minus a squared. And so now I got that square. I want to get rid of the square, right, to simplify. So do that, and then that goes away. So b equals the square root of c squared minus a squared. Now I can solve for how much b is. Okay, so let's plug in. C is 7, 7 squared. A is 2, 2 squared, and then I'm going to square root the whole thing. So that means b is equal to, 7 squared is 49, 2 squared is 4, 49 minus 4 is 45. So b is the square root of 45. And I could, if I wanted to, do that, square root of 45, and like get some number, and it's like a little bit less than 7. It's going to be 6 point something, right? But if you look at the answers in this problem, they all involve leaving this as a radical, right? So it's the same stuff you've been doing. It's just in a different form, right? So now here's my 3 sides. And now this just becomes like our first problem, right? Sine theta. What's sine? Sine is opposite over hypotenuse, right? From cot𝞱. So here's theta. What's opposite? Opposite is the side I just found, so square root of 45. So that's root 45 over hypotenuse. I said the hypotenuse is 7. Square root of 45 over 7, that's sine. How about cotangent? Cotangent is the opposite of tangent, right? So tangent is opposite over adjacent. That means cotangent is adjacent over opposite. So adjacent side, here's theta again. Adjacent is 2. And then opposite is square root of 45, right? On the other side, that's opposite. So cotangent is 2 over square root of 45. So if you notice, all of these are the same as the very first problems you did, where you were given 3 sides and you just had to solve for the trig functions. But you've had to do a couple extra steps on top, right? So on this one, I had to look at this and say, okay, cosine equals this, so I had to fit these in, adjacent, hypotenuse, right, and then see where they ended up on this triangle. And then I had to jump to the step I did in the problem before, right, in the example we did before, where I have to solve for a side. And now that I know this side that I didn't know before, I know all three sides, so now I can just start plugging in to my trig functions and solving. But again, it starts with looking at what you know and trying to fit that into the problem.